Can you see the screen?
Yes, sir.
Yes, sir.
Okay. So today we will discuss about the development length in design. Anybody knows what is meant by development length? LD.
It is the length which is embedded into the support to provide effective bond stress.
Yes. So let's say this is a concrete. Okay. And in concrete, I am embedding one rod, let's say. So let's say there is a rod like this. Okay. And if I, let's say, put one force of tension force here. So if I give the tension to this bar will try to come out from this concrete section. Yes. So this from this concrete section, this bar will try to come out, but somebody will resist this to come from coming out. Who will resist this?
The bond between concrete and reinforcement.
Yes. So see, there is a concrete here around the bar, and it is embedded into the concrete, and this there is a friction between the concrete and the rod. Okay. So that friction will resist this bar to come out. So all of you know that if this is a tension, then how the friction will be? The direction of the friction will be like this, isn't it? Opposite direction. And then there will be equilibrium equation. So there will be, let's say, a bond between the concrete and steel. Who is resisting this tension? Okay. And so that it will be in equilibrium. Now, if this length is not sufficient, then the bar may come out from this. So all of you know that whenever we design any reinforcement like Tor steel, I can say Tor steel. What is the permissible stress whenever we design this Tor steel? क्या लेते हैं permissible stress in limit state method? We have already
0.87 Fy.
Yes. So sigma st will be, sigma st means permissible stress will be 0.87 Fy. So for example, if I want to design this bar, how much maximum tension this bar can take? Let's say this diameter of this bar is 16 mm. So how much maximum tension it can take? So tension capacity will be
Sigma st into area.
so sigma st into area of bar, that is AST we can say. So sigma st is 0.87 Fy. I can say this Fy is let's say 415 for time being, and AST is 5/4 into 16 square. So how much this number will come in kilonewton?
Around 72,593. In
So
kilonewton, 72.6.
5 or 6.
5, yes, sir.
Okay. So 72.6 kilonewton will be the maximum tension capacity. So we don't allow any bar to take the tension more than this. Okay. So whenever we design any reinforcement in concrete structures, we take this much of capacity, that is 0.87 Fy, right? So whatever, so I can say from design point of view, this will be the maximum capacity of this bar. Okay. Now I know the force, so maximum force it can carry is nothing but 72.6. Now if I want this bar to be in equilibrium condition, definitely there has to be resistance also should be. So the resistance will be given by, who is giving the resistance now? So bond between concrete and steel I discussed with you, but how to calculate that? Bond means it is a friction. So what is the friction value? Let's say this is a LD value. So if I want to say give the equation of equilibrium, so sigma Fy as it is vertical direction, so sigma Fy should be 0. So this tension is minus T plus. So how to calculate the bond? We can say bond force. So the friction is given by the surface area of this bar. So what is the surface area of this bar? Surface area.
Pi dl.
Yes. So pi d, pi into diameter into L, LD. So this will be surface area, but this is not the force. It is only area. And there will be into bond stress, permissible bond stress. Okay. Tau BD I can say, and then it is equal to 0. So I know that tension, how I calculated the tension. This tension I calculated by multiplying permissible stress, that is 0.7 F, 0.87 Fy into AST. Correct. So AST I know if it is a round bar, AST is nothing but pi by 4 diameter square plus pi into phi LD to tau BD. Now if I want to calculate this, so what will be the LD value here? This phi and phi will go. Isn't it? Getting
Yes,
this?
sir.
So this will be your development length. So if you want your bar, if you want your bar to be in concrete in equilibrium condition, that means it should not come out of the concrete. Then this should be the development length you should provide for this concrete section. So what will be the value? So see now tau BD, you will ask where we get. So we get this tau BD values from the IS 456. So that is, we can say the frictional capacity between the bar and concrete, which is given in IS 456. So I think so. All of you, please start reading the IS 456 also for understanding the code and codal clauses given in the code, so that you will be familiar with this and you can find out where the numbers are given. Okay. So you can see here, this is the equation LDG 5 sigma ST divided by 4 tau BD. Okay. Sigma ST, you know that it is 0.87 Fy. And tau BD values are given in this table, 26.21 here. You can see here, right? So what is this tau BD value given? Let's say if your grade of concrete is, let's say 20. So how much will be the tau BD? 1.2. But it is, they are saying for deformed bars, please increase these values by 60%. So 1.6 into 1.2, right? Not
Yes, sir.
1.60%. So we can say 1.6. We need to multiply by 1.6 isn't it? So for M20 grade, tau BD is 1.2, but as our bars are deformed bars, that means torch steel. So 60% increment means 1.6, isn't it? कितना है गई?
1.92.
1.92. So if you want to calculate the LD, so how much will be that? 0.87 into, let's say, 415 is our grade, and diameter of bar, let's keep as 5 only, because for any diameter it will be same, and divided by 4 into tau BD is 1.92. So कितना रही है?
47.
So it will be 47.5. Okay. So if you want to provide LD, this should be the value. So generally in practice, we take these values as a round figure as a 50 into 5. So whenever we give instruction to the site on the drawing, we generally recommend this 50 into 5. But it may change if the grade of steel is different. So if it is, let's say FY is 500, so कितना आएगा वो LD? 187 into 500 into 5 divided by, how much is this?
56.
56.6.
Yes, so you can round it out to 65. So
50. Yes.
so you can say to the site on the drawing, because see, the site people don't do such kind of we can calculations on site. They need some kind of some round figure numbers like this 55 or 65. Okay, so once you give the to them the direction, then they will definitely do the 16 to 5. So if it is your 16 bar, so 16 bar के लिए कितना आएगा? Let's say 500 is our grade generally. So for 16 diameter, it will be 16 into 60. कितना आएगा? 960 mm. For 12 mm diameter, how much will be? 12 into 60. 720. Okay. So if you still want to give, say you can give the table like this on drawing, if you wish, so that the site people will understand what is the LD value for different diameters. You can even still round this to 1000 like this, or you can say round it to 750 mm. So it's your choice. You can give little more values if you want. Generally, actually, whatever bars we are designing in beam column or any other RCC structure, this stress is always less because we are putting more steel comparatively. We don't design exactly to the full stress. So we are always giving more, we can say, steel. As we are giving more steel, this value actually will be reduced. Okay, so it will be less than 56. But don't worry, don't think in that direction. Just give these numbers to the site and they will follow it. Okay. If you want to exactly calculate the LD, then you can do it, but forget. See, it is not practically possible to give LD for each and every bar and each and every beam. So it is better to give standard, we can say, formula to the site. So this is the development length concept. So development length. So we know that. So where we provide the development length in general. So this is nothing but to transfer tension to the concrete. So we are transferring tension to the concrete through this. Yes or no? So let's say if you pull this bar downward, then this tension, whatever is developed, it will be transferred here through the friction between the bar and this development length. So we are transferring through the friction, and for that friction there is a requirement of LD, because this friction value, whatever we have calculated, it requires LD here. You can see tau BD into here, LD is there, and the surface area. Okay, pi d into this. So tau BD we get it from IS code 456 for different grade of concretes, and LD we need to calculate. Okay. So you might have seen cantilever beams or simply supported beams or whatever. So cantilever beams, if I draw a cantilever beam, let's say this is a cantilever beam, and due to the load, all of you know that there will be bending moment. So how, let me break this. The bending moment will be like this, something. So there will be support bending moment and it will transfer here. Okay. Either if it is a balanced cantilever, this will be like this. If it is a continuous beam, then our bending moment may be like this. So it will be like this, then here, and then it will go down something. Okay. So you can say that the bending moment is even going back in this beam. And whenever I say bending moment, all of you know that bending moment is nothing but a tension. So there has to be some bar which will take the tension here. So I will provide this bar, but the tension is not till this point. You say that bending moment is still there on the top of this beam. So the tension is still behind the bar, behind this cantilever beam. So I need to develop this bar back into the beam. Okay, so I need to develop this bar till the development length. So whenever I show any development length, it should be from the face of the column. So from here till here, there has to be development length LD. Okay. See, all of you know that whenever it tries to bend like this beam will try to bend like this. And due to this bending, there will be tension here. So this bar will try to come out. Yes, due to this bending, this bar will try to come out from this concrete, which is embedded here. So whatever is the friction here, so there will be friction here like this. Okay. And that's why we are providing this development length. Okay. So the friction is there because there is a tension here. So this bar is having tension. Why this tension is there? Because of this moment. So there will be tension at the top and then compression at the bottom. See, all of you know. So generally compression is taken care by the concrete, tension is taken care by the steel. So I want to develop this tension into the back beam, and that I can develop through this LD value. So what will be the LD value for this? Let's say this bar diameter is 20 mm. What will be the LD value? Fy is, let's say,
57.5.
500. So it will be 57.5, or let's say round figure 65. So 60 into 20 is
1.2.
So it should be minimum 1200, so that you can transfer this. So this is general, we can say, development length philosophy. So this is for cantilever beam. So there may be some different kind of beams. Many times we may not have the, let's say, back beam. So this is your back beam for the cantilever. So I generally recommend please provide the back beam to the cantilever beams. Don't keep as it is. But if there is some, we can say, restriction, if you can't provide the back beam, then you need to transfer the cantilever moment into the column. Let's say I have a cantilever beam, but the cantilever is let's say this is your cantilever beam. So all of you know that the cantilever moment will be like this. So this will be your cantilever moment. And as you know, this is a cantilever moment. This cantilever moment will transfer in the column also like this, something like this. All of you, we have seen that problems. So this moment will transfer into this. Whenever I say this moment transfer to this, that means the tension also transfers to that. So I will provide steel here in the cantilever beam at the top. As it is a cantilever, there has to be fixity, and fixity has to be there means there needs to be development length like this. then the moment will transfer into the column. So moment transferring means we can say we are transferring the tension into that. So whatever tension is here, we are transferring this tension into this column as a tension. Okay. And then this moment will transfer. So you need to develop this. So what is the LD? So if I ask you from where should I measure the LD? So generally this is from the face of the column. So please understand these concepts should be from here to here. So this is my LD value. Okay. Depends on the bar. If it is 20, then it will be 1200 mm. So from here to here, you should measure 1200 mm. So that means I can say this will be, if your column dimension is, let's say 300 mm. So 300 mm is your column dimension, this column dimension minus cover. So generally in column we have cover as 40 mm. So ये कितना आया? This distance is 300 minus 40 is 260. So this is your 260, and how much is remaining out of 1200? So 1200 minus 260 will be कितना आएगा? 1040, isn't it? या नहीं? या 940 आएगा ये? 940.
940.
So what is this vertical height is nothing but 940. Okay. So from here to here it will be 940. Okay. So whenever you check any reinforcement on site, please check these LDs also. This is very important to check LD. Many times site people don't provide this LD. They must provide the LD. Now, if I ask you, see, do you know what is the site construction procedure? Whenever we do the construction of building, what we cast first, column or beam?
Column.
Yes, so we cast column first. So, and whenever we cast column, generally we cast column till the bottom of the beam. Okay. So
Yes,
let's
sir.
say I cast this till this. Now you will see that there is a problem to this, isn't it? Can I cast like this in the
Yes,
beginning?
sir.
Yes or no?
Yes, sir.
Actually not, because see, I need to provide this LD. How can I provide this LD bar? See, let me just draw it bigger column. Let's say this is your bigger size of column. Okay, now this is your casting level. And let's say this is your slab here, bottom slab, for example, and bottom beam. And again, there is a column like this. So I cannot cast it till that point, because if I cast this, then how can I provide this EL? Let's say I'm casting the column like this, full column. Generally we cast like this. So this is your casting of the column. But there will be problem to this EL bar, isn't it? I cannot put this
Yes,
in the
sir.
casted column. That means I cannot cast that till that level. So I need to cast till the bottom level of this. So I can say I will only cast till this level. Right?
Yes, sir.
Then what I will do, I will then put the bottom to the beam. So all of you know construction. So generally we provide the bottom plate to the forecasting formwork or shuttering, we can say like this. Then I need to again create shuttering for the column here on the both faces. Yes or no?
Yes, sir.
And then I can cast this. But generally it creates problem on site. Partly casting the column and then this additional, because there is a quality issue generally at this point. So at this point there may be quality issue. So if I ask you, if you want to avoid this, if your development length should be within the beam itself. So if I have the development length till this point only, let's say, then I can cast, isn't it? Now it is easy. If the LD is till this point only, समझो यहाँ से यहाँ तक नहीं है तो यहाँ तक ही सर. Say let's say till here LD is there. So it is very easy for me from construction point of view, so that I can cast it till the point. So I need not to again create this column shuttering. This column shuttering we have form work, we can say. So I will cast till the bottom, and because my LD is this point only. But how can I reduce the LD? Anybody? How can I reduce the LD?
Origin of 90-degree hook.
Yeah, so let's say if this is 600 beam. So previously, how much was my 940? It was previously 940. So it will go 340 here. But I am not interested in providing 940 here. I want only vertical should be 600 only maximum. And this is, we know that this is how much? 260 tha na ye. So LD should be only 860 maximum. तो कैसे प्रोवाइड करेंगे? How can I reduce the LD? LD मतलब क्या है? So if I reduce diameter of bar, then I can reduce LD, yes or no?
Yes, sir.
So whenever you design bars in beams, if you reduce the diameter, so you can choose any diameter in the design of beams. You can use 20, you can use 16, you can use 12. But all of you know that, let's say if you require 3 bars of or 2 bars of 20, let's say. You are requiring 2 bars of 20. So what is the area of 2 bars of 20? 20 का बार का एरिया कितना चाहिए?
628.
628. So my required AAST is this. Now if I want to provide this in let's say 12 mm bar, तो कितना लगेगा? 12 mm का कितना है? So total AAST is so 113. So कितने numbers आएंगे?
6 numbers है.
So roughly 6 numbers. So I can provide, instead of 220, I will provide 612. And 12 mm का LD कितना आएगा? 60 into 12. How much is this? 720.
720.
So ये 600 plus 260 कितना हमारा आ रहा था?
860.
860. So okay. So
Minus
12 mm I can.
सर माइनस तो हुक भी तो माइनस होगा वहां से.
हुक कौन सा? ये लिया ना मैंने.
बेंट जो यहाँ करेंगे सर इस पॉइंट पर 90 डिग्री तो 2D तो वहां से माइनस भी तो होगा.
Correct. So see, I'm just giving, I'm not going in detail. I'll share you the detailing code in this whenever you provide. But see, we don't go so much of detail when we design, because it is better to give some simple methods actually. Whenever you design, as far as the detailing part is concerned, it should be simple from site point of view and from design point of view also. I know that whenever you provide EL 90 degree, then it can be reduced. Okay. So this 65 you can reduce if you provide 90 degree angle. So how much will it reduce? And that there will be some difference. And this 65 will come to, let's say 55 or 45 something, depending on the, see, there are clauses given in the detailing code. Okay. But I'm just giving you idea that if you reduce the diameter, then you can reduce the LD values. Okay. So this is one important point. So generally it is better and recommended from site point of view, construction point of view. Okay. So it is your choice, but it is really not possible for you to reduce the diameter. Then definitely then site people need to compromise. So because we can't help in that case. So it will be more. So, but maximum possible, try to do like this only. And this problem comes only whenever the width of the column is less. क्योंकि ये कम आ रहा है ना मेरा, ये 300 ही है ना, I told you this much. But many times at the depth part of the column, let's say this column is having 600 depth, okay, instead of 300, then there is no problem. Yes, because this is 600 minus cover, let's say it is 550 something. So 550 and then it is 500. So or 600, let's say. Kitna aega 600, 550, 550. So it will be 1100. So I don't have any issue, even providing 20 mm bar. Okay. So these are the things you should keep in mind whenever you provide any development length. So in design also you need to think regarding the detailing part of the reinforcement. And we also provide LD in fixed beams. So fixed beams generally, so I want to tell you one thing. So whenever we design any beam, if your beam is resting on the column, okay, if your beam is resting on the column, then we generally design the beams as a fixed beams, okay, because the columns are already there who will take care of the moment, so there is no problem. This will be the case. So generally beams resting on columns we consider as a fixed beam, and as it is a fixed beam, definitely I need to provide LD. So ये ऐसे provide करना पड़ेगा L. So that's why we provide this L. And how to measure the L? From the face of the column till this. यहाँ से यहाँ तक. Okay.
Yes, sir.
So when there is a tension, there is a question of LD. There are LD for compression also. So it is not necessary that the LD is for tension. It is for compression also. But for compression, we take lesser values. Okay. They are given in the code. You can see for compression also.
Increased by 25%.
So for compression, you can increase it by bond stress. You can increase by 20%. Okay. What are the other cases where you need to provide the LD? Footing may be
Foundation.
Yes, we provide in foundation also. Let's say we have a footing. So we know that there is a bending moment in column. You know, okay, I'll do one thing. काम करता हूँ मैं. Let's say I have this column and I need to provide a footing for this column. So in column also we have tension, isn't it? Column में भी tension रहता है ना ऐसे. You know this bending moment diagram in the column, right? As there is a tension, so whenever you put or any reinforcement in the column, let's say this is your reinforcement in column. Okay. In this phase, so this bar will be in tension due to this bending moment in column. So it is similar to beam. There is a tension in column also in reinforcement. So this tension which is there in the column, I need to transfer into the footing. So I need to develop this. So how will I develop this? From here to here. ऐसे करेंगे. And then here, right? There is a tension here also on this face, so I can provide that also. यहाँ से यहाँ तक. And how should I measure the development length? It should be measured from here to here. So this is my LT. Okay. To transfer the tension here in this bar in the footing. Getting this?
Yeah, yes, sir.
So this way we can do that. And also all of you know that the footing also goes in tension due to the upward pressure. So see, footings are resting on the soil. Whenever we put any footing on the soil, there is an axial load from the column and footing. So there is a pressure on the soil here. So pressure will also exert upward pressure. We can say bearing pressure. This pressure is generated. This is nothing but resistance from the soil. So the soil will not allow this column and footing to go down into the soil. It will resist. Then and then the equilibrium equation will be there. Yes or no? So building will be static on ground, resting on ground, we can say, due to this pressure. So there is upward pressure here due to the soil. And due to this upward pressure, the footing will bend. All of you know that the footing will also try to bend like this. It will bend like this. Is my deflected shape. And when it bends, all of you know that there is a bending moment. So bending moment. And due to the bending moment, there will be tension. So यहाँ एक tension bar भी रहेगा ना. So there will be horizontal tension bar. Okay, एक minute. This is for column bars. Okay. So I am developing this tension, development length for this bending moment and tension in the column bars. But there will be tension in footing bars also, right? So the footing bars will be something like this. Horizontal bar will be there in the footing. And I need to develop this development also like this. Okay. So ये भी develop करना पड़ेगा ना. So from here to here will be the LD, right? From
Yes,
this face. So try to understand where we are measuring the development, the location from which we are transferring the moment. So यहाँ से why I am measuring LD from here, because the tension is developed here. So now from here it is transferred to the column. That's why from face of the column generally it is taken, right? Similarly here, from this top of the footing, because this tension is transferred from, because this is the footing area. So from that area, whenever it enters into the footing here, then I can measure this LD. Similarly, the bending starts from here. So it is bending from here. So I'm measuring this from here. Correct? I hope you got this. Now you can think of the development length for tension. So whenever there is a tension in RCC, you need to develop this tension into the other member if it is supported on the other members. Okay. If it is a simply supported beam, what is the case? Now, as I told you, if we are resting the beams on beams, let's say this is my so this beam is resting on this beam. This is also beam, let's say. Instead of column, there is a beam. You might have seen this cases also in buildings. Many times we rest beam on beam. And let's say this is also our, so this beam, I generally call it as a secondary beam. And these I can say primary beams because they are supporting the secondary beams. So I already told you, generally whenever we design any beams supporting on beams, we design them as a simply supported. So I generally consider this case as a simply supported. So bending moment diagram will be like this. So where is the tension in this case? At the bottom. Bottom में tension ना. So as there is a tension, I need to transfer this tension here or not. अभी ये थोड़ा question है tricky. So here you can transfer this. Correct? So the development length will be from here to here. Are you getting? Because this bar is in tension. There is a tension here. So which will be transferred here. Right? Getting?
Yes, sir.
Yes, sir.
and there is a compression, so I need not to develop the compression bar. So if I provide a bar here as a compression bar, so don't develop that bar. Okay, let's keep it as it is. Don't put L. If you put L, then there will be moment of resistance, so it will not be simply supported if you provide L here, right? So generally we, for simply supported, we just don't give any L to this, but when it is a fixed like this beam supporting on column, then I need to compulsory develop this. Then and then, if you have assumed your analysis the fixed beam, definitely your ETAP model or your analysis will show the bending moment here at the top, and it will also show the bending moment in the column which is transferred. And as if this is the analysis which you have assumed while modeling or while manual calculation, then there will be tension here. You need to provide these bars, and then you need to provide the LD also. Okay.
सर ये बॉटम बार को भी एलडी देना है क्या फिक्स साइड में?
Yeah, yes. It not compulsory. In this case, it is not compulsory because the major tension is on the top. Okay. Compulsory nahi hai yahan. But I would say we should give the instruction to the site. Please provide that also. Now, why I'm saying like this? Technically, for this low diagram, whatever bending moment diagram I have shown, it is not required. But I'm still saying that give the instruction to them, because in earthquake there is a tension at this bar also. Okay, so I'll show you the bending moment of earthquake. Earthquake means lateral load. हमने already frame का analysis देखा है ना. So whenever we provide any lateral loads, and lateral load comes due to the earthquake and wind loads. Okay, so generally if this is the column and this is your lateral load, so there will be bending moment like this. So ये बीम में ऐसे आएगा कुछ तो, and column में भी ऐसे कुछ तो आएगा. We have seen that in the analysis part study. So you see this is the bending moment here. Right? That means there is a tension at the bottom also, right? Yes or no?
Yes, sir.
And that's why in that case we require this LD. ये blue color का दिखाया ना मैंने, ये वाला. So on site it is generally I recommend give the instruction to them. As far as the beams are supporting on columns, provide EL on both for both the bars. Just to avoid the confusion, because site people are layman and they don't understand the philosophy of design. So if you feel that they will do mistake or error, please don't allow them to think. They need to follow the drawings only, and they will follow the drawings. So they will not think that where is the tension in the beam, where is the tension in column, like that. Okay. So better we give this instruction. It doesn't make any, structurally it is no problem. It is good for earthquake also. Okay. Any question?
No, sir.
Excuse me, sir.
Yes,
I have a
yes.
doubt.
Yeah.
So the general doubt not regarding this. If you are talking about the tension,
Mhm.
if we pull out the bar and if we provide sufficient LD, so LD will it will not fail in LD, but it can fail in flexure tension, the reinforcement. So
Yes. If
so
you
we
don't
have to
provide
take both into the account, LD and flexure tension failure. We
yes,
have to take.
see, flexure tension failure means, say, let's say this is your 100 kilonewton moment. Yes. Okay. This bending moment is 100 kilonewton. That means you need to design this bar for 100 kilonewton moment. How will you design that? So AST is equal to, I'll just take the simple formula. We have different formula. Mu upon sigma st J into D. Okay. You know this, how to calculate the steel. So Mu
Yes.
upon sigma st is 0.87 Fy. J is generally 0.85, means it is a lever arm factor, and D is effective depth of the beam. So I am getting AST here some mm square. Yes or no? So whatever
Yes, sir.
AST I am designing, it is for 0.87 Fy already. So I have already taken care of the flexure design whenever I design these bars. Yes. So flexure design
Yes.
is done here, and development length we are providing. All of you know that our development length is only based on this. stress, permissible stress, right?
Yes, sir.
तो दोनों के possible है, मतलब दोनों हम ले रहे हैं design में. We are not ignoring
Yes.
any kind of condition in this.
Yes, sir. This is my only doubt.
Yeah.
We have to take both or only LD. That's
Yeah, so here whenever we design, first we design this bars, number of bars we calculate first, and then we provide the LD. So actually this is your, we can say working stress, not working stress, but a simple formula like working stress. But in limit state we have formula, I think क्या दिमाग में है क्या? 0.5 FCK ना? Upon
FY.
1 minus
1 minus root of 1 minus 4.6
mu
Baba.
and,
FCK
FCK BD square
into BD.
into BD.
yeah.
Yes.
So ये इससे निकलना है. See why I have shown this formula, just because this is very easy to understand from the philosophy point of view. How it is coming? Do you know ये कैसे आ रहा है? AST into ये कैसे?
Equilibrium.
हाँ, equilibrium है. I'll just show you. अभी आया है दिमाग में तो. As we are understanding the concept, ये तो हमें पता ही चाहिए. Say I have a beam which is carrying a bending moment. यही है समझो. ये बीम निकल रहा हूँ मैं. So there is a bar here. So this bar is compression bar, don't bother much, but here there will be tension at the bottom in this case. So if I draw the force diagram, who is resisting the moment? So moment resist कर रहा है. So there will be compression and there will be tension here. Yes. Tension is developed due to this, not developed, resisted by this. And there is a lever arm like this, okay? ये lever arm है. यहाँ से यहाँ तक कितना आ रहा है? D, okay? From till the center of this bar. Now I know M is what? C into D, or M is nothing but T into D. Moment of resistance I am calculating, okay? So moment T is what? Whenever I calculate any capacity of bar, how I calculate? Sigma ST
0.8 into
Yeah,
AST.
sigma is into AST into D. Now see here, we need to multiply, reduce this D by J value, J, or I have shown here J. I need to reduce this value because see, this C is not exactly at the top because we have a parabolic shape of the concrete. So let me remove this. थोड़ा सा निकालता हूँ. Actually, our stress diagram for the concrete is something parabolic. Okay. So my C is not at the top, but somewhere here. Okay. So you can say that it is still reducing by some number. Are you getting this? This is not at the top, but this is little below.
Yes,
So
sir.
to take care of that, I am multiplying it by J here. Okay. So this will be less than one value. It is J is generally near to 0.85 something. It depends on grade of concrete and steel, but let's say 0.85. So I'm reducing this D because this is below this. So actual my effective part is this. So this is nothing but, this distance is nothing but J into D. Getting?
Yes, sir.
This is J into D. So M is equal to this. Let's say I'm taking M, ultimate moment. So if I calculate AST, how much will be this? Mu upon sigma ST J T, right? वही था ना formula. Sigma ST J T. And sigma
Yes,
ST
sir.
is 0.87F. So this is the in general philosophy. We can say this philosophy is truss analogy, simpler method. See why I am telling you the simpler method, because they are very easy to understand. I know that you need to follow this formula for calculation of AST because this is a rigorous formula based on we can say rigorous theory of RCC design by limit state method. Okay, but you follow this, but for understanding, use this. Even whenever you check the design of software given by the software, you can use these quick methods. So I say it is a quick method or thumb rule, which will also give you the accuracy of 90%, which is very good number, right? So the AST calculated by this method and AST calculated by this method should not vary more than 10%. and 10% variation in structural engineering is always acceptable. So don't worry. So do the things rigorously. So definitely whenever we design any structure, whenever we do any analysis, we do it rigorous. So we do rigorous analysis. We do the rigorous design. Okay. Generally, rigorous analysis is possible by softwares because manually there will be definitely some approximation, but software will give more to the reality, we can say. Calculation will be very exact due to the, we can say, 3D modeling in the softwares. So rigorous analysis is possible in softwares and rigorous design is also possible in softwares. But rigorous analysis and design is not possible by manual calculation. So it is difficult manually. Okay. To do, I'm not saying it is impossible, but difficult to do manually. It takes a lot of time and that's why we ignore it. Then definitely we should know what is the simple manual calculations. So we should know simple manual calculation. So whenever I simple means approximate, definitely. Then and then it can be simple. So approximate is less simple. But whenever I say simple and approximate, it is not wrong or something. But this generally I call it as a classical method. And all of you know that classical things doesn't change with respect to the time. They are always there. The software will change, technology will change, but the classical methods will not change. And why classical is important? Because it's very easy, simple, or we can say simple to understand. And if you know the classical things, there will be little error, no issue. Error will be there, little error, but there will not be any blunders. Please keep in mind. So if you want to avoid the blunders, mistakes, bigger mistake, use classical methods for checking of the results of the softwares. Okay. So whenever you develop a knowledge of structural engineering, I always recommend to the students, please learn the classical way of the structural engineering. And these are the classical ways. So whatever sessions we have taken till now, from the beginning of this month, they are all classical methods. Please try to understand. They are approximate methods. They are classical methods. But that is the, we can say, core part of the structural engineering. So I know that whenever you will learn the softwares, there will be a lot of things which will not match with this. So you need, you should understand why it is not matching and where is the difference. Okay. And ultimately develop this skill, classical skill. So that is the main part here. And that's why I'm just using very simple examples like this. Now, how it got developed, please think over it. How this formula got developed. What is this BD square and what is this J value, actual J value? What is this stress block of the concrete? Stress block already we have discussed. Stress and strain जब लिया था last time, वहाँ लिया है हमने.
Yes.
पैराबोलिक से था ना 0.67 FC के, उसको डिवाइड किया 0.44 FC के, वही है ये ब्लॉक.
Yes.
Partly rectangular and partly parabolic.
Yeah, actually partly rectangular and partly parabolic. ऐसे है वो.
Yes.
Right. So how it is coming, it depends on the strain values and so on. So you please go through the books for rigorous analysis. My intention of these sessions is not rigorous part. So you can refer the book. But my intention is simple and classical methods because the problem is this only. So I have come across with many students or even experienced people. They don't understand structural engineering, or many people feel that structural engineering is difficult. Okay. So the difficulty is not due to the subject, but it is difficulty because they don't know the classical way. and they don't know the classical way, therefore they don't understand. So my aim is from these sessions, whatever sessions I'm going to conduct, I will more focus more on these kind of concepts only. And then once you understand this, you go and refer any book for any detail calculations. So refer any book. It will give rigorous methods, and then you will understand the rigorous methods. So you will find some minor, we can say, difference in the classical method and rigorous method. So try to think over it, why it is so and why it is that. Okay. So ये बहुत है इसमें, मतलब structural engineering is a very vast subject. But in the beginning of career and even till the end of the career, I would say, please focus on this. Don't forget this part. Even though there are no softwares, you still can design the structures by using these methods. Okay, your design will be little heavy, I would say, little costly. Doesn't matter, but it will be safe. You can guarantee it is safe. I know that there are no softwares, it will be definitely costly because you need to do it manually and it will take, you need to assume on the safer and higher side. But as it is safer and higher, it will be from the classical way only. Classical means by basic principles. So you will not violate any basic principle, right? So this is your, we can say, development length and all these things. Even hence onward also, I will be sharing you certain posts through our WhatsApp group. I think you are added to technical forum group to.
Yes, sir.
I think today
Yes, sir.
we have
Today,
added.
yes, sir.
So you will be getting certain posts from me regarding the concept understanding or whatever. I will share some knowledge because I know that this topic is so vast. It cannot be only finished within such sessions. But my aim is from this session is to get the momentum towards the structural engineering, to get the interest into the subject, then to start study. So you will get the as you will get the interest, you will start studying the things, and then as you will start studying, you will get the knowledge, understanding, and so on. You'll get the experience, so on. And I will add certain things. So on the basis of concepts which I have discussed, now you will understand what I am posting you. Okay. And there will be some practical aspects, some again additional concepts which I might not have covered here due to time limitation, but you'll learn that through that. And even though you get any questions in that, please you can ask on WhatsApp or even call also. Okay, so there is no problem, but be consistent. In reading the post, I may share post, I may share some small videos or whatever, I don't know, but study material will be there. So just go through that consistently, because this knowledge only you get through consistency. So consistency is very important point here. Now let's see load and load path in RCC structure. I will take one first simple example. Just a moment. Now we have already discussed the loads in the beginning of our sessions. Now let's take one simple example of a room, single room. So let's say we have a room with these 4 beams and 4 columns. So I have these 4 columns, let's say. And this is a slab, roof slab. if you see the section of this, then it should look like this. So this is your column, and let's say this is your beam. Let's say we have one slab over here. Say S1, I just named this S1. And these beams are B1, B2, B3, B4, whatever you name. Then these are the columns C1, C2. Let's say your slab thickness is 120 mm. Then the room dimension is, let's say, 4 meter by 4 meter square. I'm just taking for simplicity square. Then beam sizes are 200 by 500 mm. Then column sizes are 300 by 300 square. Okay. So slab is there, column is there. And let's say we have a wall also. Let's say this is a one single room and where there is a parapet wall over here. Height of parapet wall, let's say 1.2 meters. Okay. Thickness of parapet wall is 0.15 meters. Now my aim is how much load will come at this point from the column. Okay. So there will be axial load in this. So what will be the load path? Can anybody tell me how the load will transfer till this? So here, let's say we have a footing here below this. ऐसे यहाँ कुछ तो footing है समझो. Okay. Here also, but okay. But I want axial load here at this point. PU. PU means ultimate at the end, because we design in RCC as a limit state method. So we take the ultimate loads. So my aim is to calculate PU at this point. So can anybody tell me how the load will transfer till this point? कैसे जा रहा है, कहाँ से कहाँ जा रहा है बताओ.
Self weight of parapet wall.
So first law, self weight of parapet wall. Okay, no issue. Self weight of, there will be self weight of parapet wall.
Self weight of beam.
Self weight of slab then.
Beam, slab. So first actually it will transfer
Column.
from slab. So from slab, so load path will be from slab to beam, and from beam to column. Then again there will be load from wall to load will transfer from wall to directly here beam. Let's say there is a beam in this direction also.
Plinth beam.
ऐसे कुछ तो है beam से. ऐसे कुछ तो है. So I'm just showing it dotted line. This is your slab and this is your beam. Yes. ये है समझो ऐसे. This is your beam. ये कौन सा B3 है ना मेरा. ये कौन सा है मेरा, let's say B1 है, और ये मेरा B4 है. and this is my S1. So from wall to directly it will transport to the beam. Yes. From wall directly it will go to the beam and then beam to column. So these are the loads. So that means you should calculate all these loads: wall load, slab load, beam load, and column load, right? Beam weight, column weight, slab weight, and wall weight or load. So how to calculate that? So if I am interested in calculating the load on column C1, so see, as there are 4 columns, it will be shared in 4 columns. Yes or no?
Yes, sir.
Correct. So as it is a symmetric, generally for approximate method I am calculating actually. So quarter part, 1/4 of this load will go into the column 1, then 1/4 in column 2. So I can say if I divide this building in 4 parts, so whatever hatch part you can see here, ये इतना वाला, so whatever is within this hatch part, that load will go on, that load will go on to the column C1. Yes or no?
Yes, sir.
So you can see here my only this portion of the beam is there. ये beam का इतना ही portion है ना. So my this beam will have this much of portion. ये इतना beam का portion, half part of the beam, then half part of this B3, then slab का भी a quarter portion, and then column, and even half part of the parapet wall also, because this half part is going on this C2. This will go on C2. This red one, this will go on C2, and even this slab will go on C2, right? Similarly here. Now that means I need to calculate this weight within this range. So first I will calculate the let's say slab load. So slab load, how to calculate? So this is your slab load. यहाँ से इतना ही है ना ये slab, right? So बताओ what is the load of slab? Slab load is how much?
20 into
Slab weight. So area, volume into, all of you know that if you want to calculate any self weight,
volume into
Volume.
density.
volume
density.
into density. So slab dimension is कितना आएगा ये slab dimension? Actually slab dimension यहाँ से यहाँ तक ही है ना, यहाँ से यहाँ
2
तक
by
है ना?
2 by 2.
Okay, for simplicity we will take 2 by 2, but this will be actual slab dimension. Okay, you need to subtract this slab width. But let's say for simplicity of calculation, I am taking 2 by 2. So half 2 meter by 2 meter. Only little higher side I am taking. Actually, it will be like this one. So it will be 2 minus 0.2. So it will be 1.8, ideally speaking. या यही लेंगे, चलो यही लेते. Okay. Not 1.8 क्या आएगा ये 1.8 ही आएगा ना. 2 minus 0.2. ये 0.2 है ना ये. और shall I take approximately 2? कैलकुलेशन आसान हो जाएगा ट्रेनिंग के लिए. समझो ये 2 ही लेता हूँ, चलो. ओके. Now slab weight is volume मतलब 2 meter by 2 meter into 0.12 into
20.
कंक्रीट है ना 25 आएगा. ओके, कितना आएगा फिर ये
12.5 kilometer per minute.
12 only.
12 आएगा ना. हाँ, 12 किलोन्यूटन आएगा ये. देन बीम का कितना आ रहा है?
2 into 2.
So ये 2 meter beam length, actually ये भी कम
दो
होगा,
नंबर.
but I'm ignoring. So 2 and ये this 2 plus 2 मतलब 4 meter के beam है ना. 2 meter plus 2 meter दोनों side के beams. So this is
Into
your
point.
length, then dimension 0.2 into
0.2
5 into concrete
25.
density. कैलकुलेट करेंगे कोई
10.
10 किलो न्यूटन ओके। अब ये बीम का पैरापेट वॉल
2+2
2+2 पैरापेट वॉल भी उतना ही रहेगा ना, ये और ये इनटू
0.15
हाइट इज 1.2 मीटर्स, थिकनेस इज 0.15 एंड डेंसिटी कितना है
20
ब्रिक का? यू कैन टेक
20
कंफर्टेबल 20 ओके। तो कितना आएगा ये
14.4.
लेट्स से 15 किलो न्यूटन राउंड फिगर ओके। सो ये पैरापेट वॉल हुआ। अभी कॉलम का हाइट में देता हूँ यहाँ तक। लेट्स से योर कॉलम हाइट इज फ्रॉम हियर टू हियर, लेट्स से इट इज 3 meters here column height. So column will be height of column 3 meters into size of column 0.3 meter by 0.3 meters into
25
कितना रही है
7.5 कुछ something
6 something
6.75.
okay। So let's say 7
Almost 7.
okay। So let's say 7 for simplicity kilonewton okay। all the loads are there now I think, isn't it? हुआ ना सब?
सर और
कुछ मिसिंग है?
लाइव लोड नहीं लेंगे
ओके हाँ। सो ठीक है लाइव लोड लेंगे। सो लेट्स से वी हैव अ लाइव लोड ऑन दिस स्लैब एज 2 किलो न्यूटन पर स्क्वायर मीटर। सो लाइव लोड कितना आएगा यहाँ स्लैब लाइव लोड? ये स्लैब विड्थ है, स्लैब लाइव लोड LL इज इक्वल टू
2 into
2 into 2 मतलब ये स्लैब का एरिया हुआ एंड लाइव लोड इज
2 किलो
2 into इतना ही हुआ ना।
हाँ
So what is the total load then?
It
On
will be 8 kilonewton, not 6.
so, कहाँ?
Slab
Live
live load.
हाँ हाँ
8 kilo.
8 yes। So 12 plus 8 20 30 45 52 So the load on column will be 52. This is your working load.
yes sir
So I can say whenever I write working load you can use this nomenclature PW. Okay, working load. Working. So what will be the ultimate load?
into 1.5
Into 1.5.
So it will be something 75
78.
78 kilonewton. Okay.
Kilonewton.
Let me say it comfortably 80 or 80 करता हूँ मैं. So this will be the load and for C1, C2, C3 it will be same because it is very symmetric. And if we have let's say 4 number of floors, समझो ऐसे है हमारा building. ये ground 1, 2, 3 and let's say 4, okay. And यहाँ मैं load निकल रहा हूँ समझो point. तो कितना आएगा मेरा load?
into 4
In this case only
Multiplied by 4.
here actually it will be parapet wall only at the roof, but here the load of the wall will be more, yes or no? ये 3 मीटर का आएगा ना?
yes sir
Yes, sir.
So what you need to do? So I can say this is your. अब बताओ अभी इसका करेंगे कैसे? So I want call PU here. So क्या कहाँ चेंज होगा बताओ इसमें? स्लैब लोड तो सेम ही रहेगा, ये सेम रहेगा, लाइव लोड सेम रहेगा.
बीम सेम रहेगा वॉल का एक्स्ट्रा आएगा
सो बीम का अभी वॉल का कॉलम का भी सेम रहेगा. सो दिस लोड इज फॉर रूफ, रूफ का ये करेक्ट. रूफ मतलब कौन सा?
पैरापेट
यहाँ तक है लोड, ये वाला
टेरेस.
ओके. सो आई कैन से PR रूफ से आया यहाँ तक. अभी यहाँ कौन सा आएगा समझो, यहाँ भी एक आएगा लोड. लेट्स से P3 बोलोगे यहाँ. सो यहाँ ये कॉलम, ये वॉल, देन ये स्लैब एंड लाइव लोड राइट. एंड ये वॉल, ये 3 मीटर का वॉल है ना. इसमें फिर ब्रिक वॉल भी ऐड होने वाला है ना इसमें. ये PR देन यहाँ तक ही है समझो ऐसे. यहाँ PR आएगा ना हमारा. देन यहाँ P4,
P4,
P3, P2,
P1.
P1 एंड देन ये निकल सकते हैं क्या?
हम्म,
पहले एक काम करता हूँ, मैं 3 मीटर का वॉल कर निकालता हूँ लोड, 3 मीटर वॉल. So this is my parapet wall and my full wall load is full wall का कितना आएगा? 2 + 2 ये 1.2 के बजाय 3 मीटर इंटू 0.15 कितना आएगा बताओ?
ये 3 मीटर की जगह कम नहीं होगा, बीम माइनस कर सकते हैं.
हाँ कर सकते हैं. अभी 3 मीटर में ये ले रहा हूँ तो ले लो ये 3 मीटर. ओके बीम बॉटम तक ही ले रहा हूँ. सो टेक इट, नो इशू.
It will be 36 kilonewton.
36 40 करो क्या इसको? ठीक है 40 करेंगे राउंड फिगर के लिए. ठीक है कैलकुलेशन आसान हो जाएगी इसलिए. यू नीड टू टेक दिस ओनली बट करेंगे राउंड फिगर. नाउ टेल मी अभी यहाँ कितना लोड आएगा? तो यहाँ तक कितना आएगा? PR
52.
PR के लिए क्या है? मेरा स्लैब लोड है, पैरापेट वॉल एंड बीम है, लेकिन कॉलम नहीं आ रहा इसमें PR में. ओके प्लीज यहाँ तक ही ले रहा हूँ. सो बताओ क्या क्या लोड आएंगे? कहाँ गए? तो ये आ रहा है 12 है.
8 है.
यहाँ लिखता हूँ मैं 12 प्लस
8
प्लस
3.
बीम का भी आएगा 10 प्लस पैरापेट वॉल भी आएगा 15 प्लस फुल वॉल तो नहीं आएगा उसमें. और कॉलम का नहीं ले रहे मैं. आई एम नॉट टेकिंग कॉलम लोड हियर बिकॉज यहाँ कॉलम नहीं है ना इसके ऊपर. यस और नो? इसके ऊपर कॉलम नहीं है एज इट इज अ रूफ. ओके आई विल टेक द कॉलम लोड एट दिस P4 लेवल. इस लेवल तक ले लूंगा ये कॉलम का लोड. ओके गेटिंग? आर यू गेटिंग दिस? तो कॉलम आई एम नॉट टेकिंग इन PR बिकॉज रूफ पे तो कॉलम नहीं है ना इसके ऊपर. यहाँ कॉलम.
Yes.
सो लेट्स इग्नोर दैट. सो ये कितना आएगा? इक्वल टू 45 राइट.
Yes, sir.
अभी P4 बताओ. P4 में तो ये 12 आएगा, ये 8 आने वाला है ना. ये क्या है? 8 लाइव लोड है. हाँ देन बीम का भी 10 आएगा और पैरापिट का 15 था लेकिन हमारा फुल लोड है अभी 40
40.
एंड कॉलम का भी आएगा अभी इस केस में क्योंकि P4 में ये कॉलम आने वाला है ये वाला. तो कॉलम का कितना है? 7. नाउ ये P4 को भी कितना आएगा ये बताओ? टोटल समेशन
27.
कितना? हाँ
27.
$77.
नाउ ये P4 77 है, P3 भी 77 ही आएगा ना.
Yes, sir.
ये देखो ये
Symmetry.
P2 भी आएगा और P1 भी आएगा.
P1 भी
P2
आएगा.
P1 सभी आएंगे मतलब P2 P1 ये ऑल विल बी 77. अभी यहाँ क्या होगा? P1 हुआ ना.
Yes, sir.
ये PG बोलता हूँ मैं यहाँ. PG कितना आएगा बताओ ग्राउंड फ्लोर पे? So all of you know that whenever we have a building, we generally don't have a slab at plinth level. ये P1 मतलब plinth है. Yes or no? plinth पे slab रहते क्या कभी? Do we have a slab at plinth level in general?
No, sir.
Because we rest that PCC on the ground itself, so there is no slab. मतलब अभी लोड क्या क्या आएंगे मेरे? PG में ये 12 कौन था? स्लैब वेट है. 8 कौन है? लाइव लोड है. सो 12 and 8 विल नॉट बी देयर. लाइव लोड भी नहीं रहेगा और ये भी नहीं रहेगा. बीम का रहेगा 10 10 ये 10 प्लस 10 इज फॉर व्हाट? बीम तो रहते हैं जनरली प्लिंथ बीम्स.
Plain beam.
विल देयर बी वॉल? इट डिपेंड्स ऑन यू. अगर ये पार्किंग रहेगा आपका. नहीं हम कौन सा निकल रहे? PG निकल रहे हैं ना. हाँ
PG निकाल रहे सर.
हाँ तो जनरली प्लिंथ के बिलो वॉल भी नहीं रहती ना. ये
एक
portion
वन साइडेड वॉल रहती है सर.
यहाँ वॉल.
ओपन पार्किंग हुआ तो नहीं होगा.
नहीं अभी ये मैं पार्किंग नहीं बोल रहा हूँ, नॉर्मल बिल्डिंग ही बोल रहा हूँ. ये ग्राउंड मतलब ये आई मीन टू से ये बिलो ग्राउंड है एक्चुअली. बिलो GLA।
बेसमेंट।
अभी ये निकल रहे हैं हम, PG मतलब ये बोल रहा हूँ मैं, फुटिंग के लेवल पे जो आ रहा है फोर्स, ये वाला। सो देर इज अ बीम हियर, देर इज नो स्लैब ओवर हियर, नो लाइव लोड हियर, एंड देर इज दिस कॉलम भी रहेगा, लेकिन कॉलम का वेट रहेगा सिर्फ। सो बीम वेट एंड कॉलम वेट विल बी देयर ओनली, यस और नो? तो कॉलम वेट कितना है मेरा 7। अगर इफ द कॉलम हाइट इज 3 मीटर, इफ दिस इज ऑल्सो 3 मीटर, देन इट विल बी 7। ये 7 रहेगा, करेक्ट है ना? एनीथिंग
sir.
रॉन्ग? बीम वेट एंड कॉलम वेट ओनली, दैट्स इट, करेक्ट? ये भी रहेगा ना वॉल लोड?
वॉल लोड तो रहेगा ही सर।
ये वॉल रहेगा ना यहाँ का, ये इस पे जा रहा है ना लोड।
हाँ,
तो वॉल कितना है हमारा लोड? फुल लोड 40,
40 किलोमीटर।
57. So these will be the all loads which will come from all the top to the bottom. And footing अगर लेना होगा तो footing, I am calculating the load at this level only. If you want to calculate the load at this level, then you need to add the self weight of the footing also. Yes.
यस सर।
So I'm interested at this
Yes,
point
sir.
only. Okay. So ये total कितना आएगा फिर मेरा at
410, 410.
yeah. So this will be the load on that column. And if you want to design the column only for, let's say, axial load, so ये मेरा जो column है ये, this I will design for, अभी यहाँ लिखता हूँ मैं, so at this point ये मेरा लोड कितना आ रहा है? ये 410, correct? At this point, that means if you want to design this column, you will design this for this load. अभी यहाँ कितना लोड आएगा ये लेवल पे? ये माइनस करना पड़ेगा ना, ये PG वाला। So PG कितना है हमारा? से 57. So I need to subtract this 57 from this. कितना आएगा? 350.
353.
Okay, so it will be 353 kilonewton. इसमें यहाँ कितना आएगा? माइनस ये सिंगल फ्लोर का 77 माइनस करना पड़ेगा। So 353 minus 57 बताओ।
276.
276 माइनस अगेन 70, ये 200 आएगा लगभग। एंड अगेन 76 माइनस 77 माइनस करना पड़ेगा ना, मतलब 133, राइट?
122 almost.
123 एक्चुअली। ओके फाइन।
Yes, sir.
एंड ये यहाँ कितना आ रहा है? यहाँ तो नो नीड बिकॉज यहाँ कॉलम ही नहीं है ना। सो नाउ इफ यू वांट टू डिजाइन दिस कॉलम, ये वाला कॉलम, ये you will design for this. If you want to design this column, you will design for this. समझ में आया कुछ?
Yes, sir.
So these will be the axial loads for column. Now ये सब हमने वर्किंग लोड लिया है, डोंट फॉरगेट दीज आर वर्किंग लोड्स। हाँ, PW है ना ये PW से कर रहे थे हम अभी तक। So if you want to do it PU, then you need to multiply all these numbers by 1.5.
1.5.
Then you can design for that. So this is general, we can say, load path in buildings, and this is a approximate method of calculating load on the columns. See, this method will help you to check the results of softwares approximately. Okay, एक अंदाजा चाहिए ना, समझो बिल्डिंग रहेगी, ये 4 मीटर बाय 4 मीटर की रूम रहेगी, तो कितना आएगा लोड? So for getting the judgment, and that's why I have used these numbers to the round numbers. ये मैं round कर रहा था, आपको लगेगा यार क्या चल रहा है, इतना approximate क्यों कर रहे? I'm not interested to go into the digital accuracy, but I'm trying to understand the general numbers. मतलब ये 400 आया इस पे. So you can give we can think that if the room is having size of 4 meter by 4 meter, the approximate load on the column will be something 400 kilonewton if these are the floors, or it will be 77 kilonewton for single floor. समझ में आया? Now whenever you
Yes,
look at a plan of any building, then you will understand, this column base, it will be something 100, it will be something 200, it will be something 500. So you will have a judgment ki just look at the column and you will get the numbers. समझ में आया? Let's say if it is
बहुत
your plan, so it will give you a feeling, general feeling. So if this is a plan, let's say for example, normal it's a flat apartment building, 1 BHK. And when you look at a column, and then you will get a feeling, यार इस पे 1000 load आएगा, 500 load आएगा, 700 आएगा, 2000 आएगा. So you get that number. So now I'll tell you one why I have used these numbers as a round figure numbers for. So even comfortably I will say 400 kilonewton here. I can say here 75 kilonewton to 100 kilonewton. I'm just rounding these numbers. Instead of 77, I'm just saying 75. Instead of 57, let's say 60. Here also see 8 or 10, 15, 40. Okay. Now, why I'm using such an approximate way in training you here? The reason behind, as I already told you, the classical way. Human mind can understand the simple things. If I ask you to remember such numbers, let's say I give you guideline. If your room is 4.4 by 4 meters, then the load in one floor, it comes out to be 73.432 kilonewton. Okay. If it is a 3 meter by 3 meter, then the number comes out to be, let's say, 47.731. Do you really think that you can remember such kind of numbers? And will you connect to these numbers? ऐसे कभी होगा क्या?
It
Your
will be
brain,
difficult.
it will be
Yes, sir.
difficult, and ultimately you will forget it, or ultimately you will ignore it. Human mind cannot accept complex things. Please try to understand. See, that is a human mind. It is not something that you are lazy or you are ignoring or you are trying to avoid. See, brain has a capacity. But if I ask you, the 4 by 4 meter is having a load of 100 kilonewton, approximately 3 meter by 3 meter का लगभग 50 kilonewton रहता है load. Now these numbers are now connecting to you because they are very easy and round numbers. So then that's why whenever you use any approximate methods, please use such numbers. You can definitely use, no issue. Okay, because see, you want to understand, you want to get a feel of the structure, you want to get the feel of loading. कितना आएगा अंदाजा, अप्रोक्सीमेटली बोल रहा हूँ. हम क्या एक्यूरेट नहीं कर रहे. एक्यूरेसी के लिए सॉफ्टवेयर है. सो डोंट वरी अबाउट दैट. एक्यूरेट कैलकुलेशन डिजिटल जो कर रहे हैं, सॉफ्टवेयर किसके लिए है ना. कैलकुलेटर किसके लिए है, सॉफ्टवेयर किसके लिए, ये तो काम है ना उसका, मशीन का. Machine are there to give this kind of numbers. See, even I check results of the softwares in our company for any projects. I really don't bother about these numbers. I just, isko main na, in my mind, I just consider this 73 as a 75. I consider this as a 50. I consider this 410 as a roughly 400. So that I get connected to these numbers. So let's say this software is giving this number as, let's say this column is giving me number as say 1133. So I will just consider it as say 1200. If it is giving something 857.3, I will consider it as a 900 or 850 round figure. 850, 1200, 400, 600. And then I get connected to all the columns which I see on this plan. And I even remember that, say subconsciously, we can say. And whenever somebody comes to me with the software results, and I am checking the result of, let's say, software column loads and all this. By looking at the column and by looking at the software result, I just quickly understand whether the results are right or wrong. So who is helping me in this kind of understanding? See, many students also ask me how you understand that it is wrong or it is right. See, these are the classical ways. If you really develop these ways, you also can do that. So there is nothing great in experts or experienced people. Nothing great. They follow such kind of tricks and classical methods, and that's why you feel that they are really great. It is not great or something. The people are human being only. So you can become also very expert in the field, but you should know how to become that expert. So ये है, इसलिए मैंने ये this problem is one is load path and how to calculate the load on columns is the one case, and second is understand the classical way of the numbers. So you can get that feel. So ये समझ के ले लो. See, क्योंकि क्या होता है अगर ये नंबर सी आई नो दैट ऑन द पेपर पीपल डू ये 3 डिजिट के कैलकुलेशन करते हैं. I don't say they are wrong, but I say that it will be really difficult to understand. आपका अंडरस्टैंडिंग लूज हो जाएगा क्योंकि आप कनेक्ट नहीं हो सकोगे. And if you don't connect to the problem, if you don't connect to the numbers, then confidence कहाँ से आएगा? कॉन्फिडेंस आने के लिए तो यही तो चाहिए ना. कॉन्फिडेंस इज नथिंग. कॉन्फिडेंस इज वेरी सिंपल एस्पेक्ट. कुछ अलग और कुछ कॉम्प्लेक्स नहीं है कॉन्फिडेंस. कॉन्फिडेंस कम्स थ्रू सिंपल थिंग ओनली. And that's why I suggest all of you, please, if you get any complex problem, complex means in the beginning you feel that it is a complex. Please convert that complex problem into simple, which you can understand. And then solve it. Solve it, understand it, and again go to the complex problem and let the software solve this. Then whatever software is giving the results, again make it simple so that you can understand. And यही साइकिल है. So keep the complex thing aside. जो आपको समझ में आता है उतना ही करो. Complex things सिर्फ जज करो कि ये सही है गलत है. Finally we follow the software results provided they are acceptable. Blindly कुछ नहीं follow करते हम. So please read or rather I would say see my videos, whatever sessions we have taken. Please think over the thing, whatever smallest part I have discussed with you. Give we can say your thinking also to that. Create questions. Try to understand what is the I can say the meaning behind my whatever I'm telling you. And questions रहेंगे तो you can ask me. There is no problem. Okay. So abhi, let's say this is your plan in front of you, and if I ask you to calculate the load of, let's say कौन सा लेंगे, C9 का लेंगे चलो. तो C9 पे लोड कितना आएगा बताओ. मेथड प्रोसेस बताओ. So we will not calculate anything. You know कि सेल्फ वेट ऑफ बीम कैसे निकलना है स्लैब का, लेकिन कितना लोड कहाँ जाएगा वो चाहिए हमें. Approximately load path I would say.
Load of slab S4, S3, S4.
हाँ S3 S4 कितना लेकिन.
Quarter of A3.
Yes, quarter of slab, right.
And the beams B12, B11 and B30 and B31.
Yes, so
And then wall.
let's say this is S4 and ये B31 है, तो इसका आधा मतलब यहाँ तक. ओके, ये I will just ये B30 को हाफ कर रहा हूँ मैं, B11 को भी हाफ करता हूँ मैं. So this will be my slab load, right. Then beam भी उतना ही रहेगा, हाफ ये वाला beam. So this will be my इतना beam का load रहेगा मेरा. Let's say this is my beam. Again this portion of B11 का इतना रहेगा load, self weight. Okay. So this is for from S4 and these beams. Then there will be again B12. अभी B12 समझो यहाँ तक मैं निकालता हूँ for the time being. ये half समझो. अभी approximate ही निकाल रहे थोड़ा. Then यहाँ ये वाला B30 half load. And slab के लिए कितना रहेगा? अभी थोड़ा सा यहाँ अंडरस्टैंडिंग बढ़ाना पड़ेगा आपको. अभी ये स्लैब तो पूरा ही आने वाला बिकॉज दिस अदर स्लैब विल गो हियर इन दिस C10 पे, तो ये पूरा लेंगे हम, ये वाला पूरा. ओके, यहाँ हाफ नहीं ले रहा हूँ, प्लीज कीप इन माइंड बिकॉज माय C9 to C10 यहाँ तक है, मतलब यहाँ तक ले रहा हूँ मैं, और you can draw here till this, and then the B31 यहाँ तक, B33 sorry, and ये, and then again here and here, ये वाला again here. So self weight of slab, self weight of this slab, and live load also. If there is live load, you need to calculate live load. So in short, I would say this will be my contributory area of the column C9. समझो L बोलता हूँ मैं इसको, और इसको B बोलता हूँ समझो. So this will be my contributory approximate area of the slab. So अगर मैं ऐसे S4 को भी अलग से निकाल सकता हूँ, if the slab thickness is same, S4 S3 का slab thickness same रहेगा समझो, तो फिर I can directly take this L and this B and multiply that with the self weight of the slab. Now this is for C9. अगर let's say if I ask you for C2, C2 का कैसे रहेगा फिर? यहाँ तक मैं ड्रॉ करता हूँ, ऐसे यहाँ से let's say here and again here B25 का half. So this will be my contributory area in which whatever comes you need to take the load. Correct? समझ में? अभी ये ऐसे बीम्स आते हैं तो थोड़ा अप्रोक्सीमेशन और करना पड़ेगा आपको, बट ठीक है, एज अ फर्स्ट सेशन अंडरस्टैंड दिस वे. और कॉर्नर पे यहां गॉट दिस.
Yes, sir.
And once you calculate the, let's say C2 का load निकालो, तो then multiply by number of floors. Easy है वो, समझो 10 floors रहेंगे तो 10 into whatever load you calculated for one floor. Let's say ये हमारा 150 kilonewton है समझो for on C2. So 10 into 150, it will be 1500 kilonewton for 10 floors. Okay, let's say it is working load, and 1500 kilonewton working PW, and if you want ultimate, then multiply this 1500 into 1.5, something 225 kilonewton. Okay. Fine. Okay, any other questions, please? Any questions?
So I have a general question
Okay.
regarding this plan and all these things.
Mhm,
So if suppose a firm is getting a project, a big project like a high-rise building, then how the work is distributed among the persons? Suppose the person is getting only to analyze a single floor, or like you said that we have calculated the loads on different stories. So
mhm,
how the work is distributed among the employees, or
mhm. Okay,
that
I'll tell
suppose
you.
you have to calculate the load on this column, or suppose you are calculating the load on particular portion only.
Okay. First of all, you should know all the things which you will learn in the training. That is first case. If you want to become the expert and knowledgeable structural engineer, then you should know how to do the model, how to do the ETAB, how to do the design, how to check the manual manually, then how to prepare the drawings. So you should be involved in all processes in the structural engineering. But in the bigger firms, what we generally they do, say, so there is a senior person available, always senior structural engineer, let's say, who is the main or lead person. So senior person, there is a team of people under him. Okay. So he will guide to prepare the concept framing. So I think last time I have taken the one workshop on Sunday. So
Yes.
concept framing. So that concept framing is generally prepared by this structural engineer, senior structural engineer. Concept framing is based on the architectural drawings and discussions, meeting held with the clients and architects. Okay. and we prepare this concept drawing. This is nothing but this drawing. Okay, ye wala, ye beams dalna, ye sab framing. So the first is the concept framing is done in AutoCAD. For AutoCAD, generally draftsman or engineer helps. There may be engineer, structural engineer, civil engineer who is preparing the drawing in AutoCAD. So there I can say there is AutoCAD team first who is helping to in preparation of drawings. Then there is a person, nowadays bigger firms are having a person who is doing the modeling. So I can say engineer is doing modeling, ETABS modeling. So he's modeling, then putting the gravity load, earthquake loads. He's doing the analysis, then he's checking the results and so on. So ETABS modeling is done. Then there is a design team. So in design team, either RCDC software is used or Excels are used. So he can use any methods. So he will design the members, design of column, design of slabs, design of this, that. There is a possibility that in design also slab is designed by somebody else, beam is designed by somebody else, column and footings are designed by somebody else. So there may be team of engineers.
Yes,
The
sir.
project is very big. So slab beam design and then column footing design are done by separate engineers. Then there is a person who may be using RCDC software, maybe person who is doing that, somebody else. Okay. Now this is design, and then again drawing, structural drawings are prepared in AutoCAD. So these design person will give the guidance to the AutoCAD person that you give this size, put this schedule in the AutoCAD, schedule of beams, schedule of footings or whatever. So this layout I have shown you. So there are many layouts developed in the AutoCAD. Yeah, hai kya dekhta hu main. So there are lot of drawings. Okay. So drawings may be, so in AutoCAD drawings, if it is a building, then we have a foundation drawing or footing drawing, let's say. So footing drawing is having schedule of footing, that is reinforcement sizes and so on. There may be details like I told you that cross section of footing, development length, lap length and so on. So footing drawing carries this, and then footing layout, plan of footing. You will see that in training, but okay. So there will be one drawing is footing drawing, then second drawing is plinth beam drawing. Then third drawing is let's say first floor drawing, including all beam design and slab design, first floor drawing. Fourth will be second floor, third, fourth, whatever I say. Then there will be staircase cap at the roof, staircase cap and terrace layout, let's say terrace floor. Then there may be water tanks, underground tanks in buildings, whatever we use, or there may be overhead tanks. Okay. And there may be some standard drawings also, beam drawings, column drawings, standard, which the site people follow, standard drawings. So you can say there is a list of deliverables. Footing drawing, let's say 1, 2, 3, 4. Let's say we have 25 number of drawings. These are prepared by AutoCAD engineers or draftsman, we can say. So there is a 25. So this is deliverables. Whatever we submit to the site, we call it as a deliverables. And we also submit the model also, ETABS model. Generally, it is submitted to the peer checking. And we also submit the RCDC file of design, then Excel programs, and there may be calculation reports also. Calculation reports, which also submit to this. So there is a ETABS model. So deliverables are 25 drawings. Then there is a ETABS model. It is also deliverable. Then there is a RCDC design file, or we can say calculation reports. Then there is a design basis report, DBR. It is input also, input design basis, and there is output design basis. You are going to learn this all in training, but okay. So these are the deliverables: 25 drawings, ETABS model, RCDC design calculations, design basis reports. So drawings are prepared by AutoCAD draftsman, ETABS model is done by some engineer, RCDC is done by some engineer, and design basis is also prepared by some engineer. And even it may happen that if the drawings are 25, then say 5 drawings are prepared by one engineer, 5 are prepared by other engineer, 5 are prepared by other engineer, like that. Depends on how much volume is there of the work. The team is distributed. So these people
Yes.
are working separately. but they coordinate with this senior structural engineer, and this senior structural engineer knows each and every part of the structure. He knows the client requirement, he knows the architectural requirement, and he knows what every engineer is doing in the company. And he is finally coordinating each and integrating them together, because final output should be perfect. Otherwise, it may happen that ETAP model has assumed simple connection or simply supported. Design is done by fixed connection. Drawing is also given by some other detail like fixed connection or what. So if there is some discrepancy within each team, AutoCAD, ETAP, and design, then there will be really havoc and problem to the site, and even design or safety part of the project. So that integration is taken care by the senior person. And in even this also, there is a checking. Everybody checking their work. First, self-checking they do whether it is correct. Then there is a peer. So senior engineer will be there. Senior engineer checks, does the peer checking. And there is a finally, we can say, reviewer. So if there may be consultant, senior consultant above him, senior or chief consultant, we can say, he will review. So through three methods, the drawings and model and design gets checked, so that there will not be any error or mistake in the design and drawing. Okay, so these are the, I can say, this is the organization structure generally company has.
Yes, so
And
now I
yeah,
got it.
yes. And my aim is that you should learn through this perspective, or by sitting at this position, at least within the training. I don't know once you get the job where you will be located, but you must know this, because if you want to really reach to this position, senior position, you should know all the things together. Then and then you can quickly or very easily reach to this position. Otherwise, what happens? Now I will tell you the we can say lacuna or fault of this system in the companies. See, there are many big companies, MNCs, and local firms. What happens? Due to this system, the company is getting the benefit, no problem. They are getting projects, the projects are given to the client, they are getting the money and so on. But let's say if you are working in a company where you are only working on the ETAP model, let's say, and you are having experience of 3 years of doing ETAP modeling only, and you don't know how the drawings are prepared, you don't know how the design is done. That means you are not having full experience, or you don't know how the concept framing is done. So you are incomplete engineer, I would say, even though you are having a 3 years of experience. And that incompleteness is always there, even though you are experienced in such a way. So, and what happens due to this, the confidence is not there in you as a structural engineer. So you will always feel lagging, that I don't know this, I don't know that. So at first instance, I would say, don't get trapped into such system. In our training, please try to get as far as knowledge all the together, so that you will get the full holistic picture of the structural projects. Okay, so please sit on this we can say chair while studying and getting the training. So that, because see, this system is really dangerous if you are a beginner. Okay, and if you don't know anything about structural, then it see there are people I have seen, I have taken some interviews also for students or candidates or freshers or even experienced people like this. See, if I ask them, have you done the footing design, he says, no, I have done only modeling. Some people comes, have you checked any AutoCAD drawings prepared by the draftsman? No, he says, I have done only design. So some do design, some do model, but they don't know all together. So please don't get trapped into this system. Better learn many possible things here in our training, so that you will not be trapped here. I know that even though after you get this, any part of this role, you are still aware of the ETAB, you are still aware of the AutoCAD, you are still aware of the design calculation, DBR and so on. तो आपको ये सब पता चाहिए. Okay?
Yes, sir.
Yeah. Yes, Avinash.
सर एक बात, साइट एक्सपीरियंस काउंटेबल होता है जब हम प्रोफाइल चेंज करते हैं तो?
Yes, definitely होता है ना.
ओके सर.
See, experience आपका रहने दो कोई भी, it counts. I know that core part नहीं है, लेकिन experience is there because see, you have worked on projects ना, तो आपको projects, how the project is executed, what is the organization structure, how to coordinate with the people, how to communicate with the people, how to take a command of the project, ये सब सीखते हैं ना, site रहने दो या कोई भी
Yes.
रहने दो project.
Yes, sir.
So there is no problem in that. Site रहने दो या structural रहने दो. Every experience counts. The only thing is कि if you want to get do the specialization in structural engineering, then you need to work more in this field. That is the only thing. बाकी कुछ नहीं है. बाकी count होते हैं सब.
Okay.
In my initial career, I worked as a site engineer for 2 years. Then I shifted to structural engineering. Then I did my master's. So yeah, it's a career you can do. I would say career कैसे भी कर सकते हैं आप. ऐसे कुछ नहीं है बड़ी बात. सिर्फ इंटरेस्ट चाहिए सब्जेक्ट में. Okay. So shall we close?
Yes, sir.
Yes, sir.
Yeah. Thank you all.
Good
Good
night,
night
sir.
to all.
Thank you, sir.
Thank you, sir.
Good night. Good night.
Good night, sir.
Good night.